Lab 1, Charged Tapes by Anna Catherine Brewer. Introduction. The purpose of this lab is to determine the excess charge on one piece of U-tape. We will also examine interactions between charged tape and other objects, whether they are neutral or charged. I will create two pieces of charged U-tape by ripping the tape off a piece of base tape. I will then find the charge of the tape by moving a known negatively charged object towards it. I will find the excess charge on the tape by finding the distance needed for one piece of tape to float above the other. The main result of this lab will be to display the repulsive and attractive effects of point charges. The key physics concepts for this lab are electric fields, point charges, where like charges repel and opposite charges attract, superposition, Newton's second and third law, and Coulomb's law. The figures shown to the right can display the concepts I was just talking about. I'm using the above concepts because they explain how the pieces of U-tape will interact with each other. Before starting this lab, I will assume that there is no air resistance, each piece of tape has the same overall net charge, and that the charge of each piece of tape will be centralized in the center of the tape. I define the system as the charged piece of U-tape. I define the surroundings as everything else. The initial conditions are as follows. Where the tape length was 0.2 meters, the tape width was 0.02 meters, the distance between tapes were 0.014 meters, and the tape's mass was 0.0002 kilograms. For my experimental procedure, I first created two pieces of charged U-tape by placing a piece of base tape on a table. I then placed tape over it and created a charge by ripping it off. Next, I observed the charge of the U-tape by hanging it on said table and observing how it reacted when I brought my hand close towards it. I then observed the reaction between the two pieces of U-tape. I then observed the tape's reaction with a plastic object. Next, I suspended one of the pieces of U-tape and brought the other piece of U-tape close to it and observed its floating motion. For my calculations, I first found the magnitude of the gravitational force on tape B. The tape was 0.2 meters and the mass was 1 gram per meter. We can calculate the mass of the tape as 0.002 kilograms. I used F equals mg, which resulted in a gravitational force of 0.00196 newtons. Next, I found the separation distance where tape B floats. Said distance was 0.014 meters. I then found the charge on tape B. mg on tape B is equal to the electric field force on tape B because the sum of the two forces has to equal 0. Hence, the electric field force on tape B is 0.00196 newtons. Using this, I solved for the charge of tape B with Coulomb's law. Next, I calculated the number of excess electrons on tape B by dividing the total charge of the tape by the charge of one electron. Therefore, the number of electrons in excess was 4.08 times 10 to the 10 electrons. Then I found the number of atoms on the sticky side of the tape by doing the math below. This resulted in 4 times 10 to the 17 atoms. Lastly, I found the amount of electrons in excess to the total number of atoms on the sticky side by doing the math below. This resulted in 1.02 times 10 to the negative 7 electrons lost per atom. Here's my GlowScript code, and here's the output of that code. Observations. The U-tape was positively charged, and the two pieces of U-tape had the same charge and displayed a repulsive force. No observable attraction or repulsion was observed when brought into contact with a neutral item. Discussion. The U-tape displayed similar results to what physics models may have predicted. This can be explained by the fact that the two pieces of tape repelled each other, causing a floating motion. This is because of their like charges. Possible sources of error for this lab include the tape differing in size from the manual, causing slight error in calculations having to do with mass and area. Concluding thoughts. So what if electrons had a positive charge and protons had a negative charge? What would you change about the observations you made with your tapes and other charged objects? I would say that the interactions would not change because they have the same physical properties persist, like charges repel and opposite charges attract. And why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? And I would say when coming into contact with my hand or another object, electrons will transfer. This changes the charge of the tape and can tamper with the results of the experiment. Thank you for watching, and here's a link to my GlowScript code.